Okay, I think in the interest of time, we'll go ahead and get started and hope some others can join in once we get to the meat of it here. So welcome to ERP Suites, Find Your Cloud webinar series, and this week featuring Oracle Cloud Infrastructure, or OCI. And that takes us to a familiar Oracle Safe Harbor statement. And that's exciting because we have Clayton Seeley on with us today, and he's going to be sharing some future functionality. So we look forward to that. Something we haven't included in the previous two webinars, but here is a cloud pricing statement, and that's just to remind everybody that the pricing and the comparisons that we're going through today and that we've gone through in previous presentations in this series, they're based on on-demand rates, and that's just to keep everything apples to apples. Certainly keep in mind that if you're watching this a month from now, 2 months from now, 2 years from now, those rates may have changed slightly. As well, there are always opportunities to examine your personal circumstances to get the best rate for your situation. Our presenters today, you are familiar with Frank Jordan and Paul Scheer, and today they're joined by Tony Trudeau. He's our ERP Suites Strategic Projects Architect. And as I mentioned, Clayton Seeley, who, if you are not familiar, if you haven't had the privilege of meeting Clayton yet, he is one of Oracle's top technical architects. In case we have a few new faces on the call who haven't been able to join us previously, just real quickly to give you a little bit about who we are, ERP Suites is a comprehensive technology solution company. And we've been providing cloud services and JD Edwards managed services for a little over 15 years now. But above all, we strive to help our customers realize IT's potential and improve efficiency and increase margins. And today we talk about how we can do that through cloud technologies. Our agenda this week is a little bit different. For one, we're ending 15 minutes later to accommodate lots of great content that Clayton's bringing to the table as well. And we won't have time for Q&A, but please just remember that you can reach out to us anytime after the webinar and ask questions. We will certainly have the team follow up. So Tony, let's get started with some fast facts about OCI.
Thanks, Dan. So a lot of us probably think Oracle is mainly focused on enterprise software and databases. But actually, over the past several years, they've invested heavily into the creation of their cloud offering and become a serious contender in the space. So Oracle Cloud is considered a second-generation cloud platform that they're designed to cater more towards enterprise current needs. First-generation cloud platforms like AWS generally cater to net new applications, lots of DevOps. So with years of experience, though, working hands-on with enterprises on-premise, Oracle's got firsthand knowledge of what's actually needed by their customers. They've filled the gap left by the other cloud providers. Oracle Cloud fits very well with businesses that run traditional applications like JD Edwards from a performance, security, and cost perspective.
Thanks, Tony, for that overview. So before we get into a lot of the gory details, can you tell us about some common misconceptions you hear regarding OCI?
Sure. So I know a lot of customers believe that OCI just isn't a good platform for Windows to run on, and they tend to have a lot of Windows. So the truth, though, it is OCI does have some of the lowest Windows costs on any cloud out there, and that even includes Microsoft's Azure. We'll come back to that, though, in a few minutes with some specific examples. So a lot of customers also believe that running SQL in OCI is too expensive, and it can seem that way. So if you're using a license included SKU and you're doing licensing through Oracle, it can feel pretty high. But it is important to note that unlike AWS, OCI, you're allowed to bring your own license. So if you already have SQL licensing, you could bring that over, and all of a sudden OCI becomes extremely competitive in that respect.
Actually, one of the largest projects, JD Edwards project specifically, that I've done on OCI involved converting a customer off of iSeries and bringing them over to SQL Server. So the customer was literally running thousands of users, had a huge batch load, and we migrated that entire thing, landed it on SQL Enterprise Edition, running on OCI. They were able to BYOL through the Microsoft Mobility program. And really, it was the kind of the outstanding cloud choice from both a TCO and from a performance standpoint. And we'll get into a little bit later why that was the case.
Yeah, that's one of the things about E1 platform migrations. They can be challenging to get the right sizing the way you need it. But that is one of the strengths of the Oracle Cloud is you can typically adjust your infrastructure or add servers relatively quickly.
So today we're going to be talking about JD Edwards on OCI. Previously, we had discussed JD Edwards on AWS and on Azure. We had started out those other presentations with discussions on why you might want to run JD Edwards on those specific clouds. So for example, last week we talked about maybe you're running an older version of JD Edwards, you're off maintenance, or for some other reason you can't upgrade, and you've got a lot of Windows 2008 or SQL 2008 in your environment. If that was the case, Azure was a great option for you because that's the only cloud where you can actually get security patches for those specific workloads. So after we talked about that, we delved into a deep dive on JD Edwards and specifically how to make it perform well on those other clouds, as well as talking about the economics. One of the reason our content's a little bit different today is that for OCI, the performance and the economics is the reason you want to run there. So let's start out with the economics. Tony, can you talk us through some of those details?
Yeah, sure thing, Paul. So for this comparison we're going to do here, we're going to be using pay-as-you-go pricing, and we're going to use it from the four main cloud providers, that'd be AWS, Microsoft, Azure, Google Cloud, and Oracle. We're going to be comparing like-for-like servers as far as size and performance concerned. And each server is in their respective cloud members, high memory server instance class with 4 CPUs, 32 gigs of memory. And we're not adding storage to this because we're going to talk about storage separately here in a few minutes. So starting with Azure, you can expect to pay around $318 per month for the instance class with 4 CPUs and 32 gigs of memory. AWS comes in around the exact same price. And Google Cloud comes in a little bit higher, but they are negligible at $321. OCI comes in over $100 cheaper. So this is a per month cost, and that's, if we do basic math, $1,300 roughly a year cheaper. And when you have, hundreds of servers, that can really add up fast. So for JD Edwards, we know there's 2 supported Linux options, Red Hat and Oracle Enterprise Linux. So we're going to use another example here, using the same hardware capacity as before, but we're gonna use the licensed version of Linux instead of Windows here, and we're gonna look at the on-demand rates. So for Microsoft and AWS, actually, they're the same price at $228 a month, and that's using Red Hat. Google also using Red Hat is a bit higher at $259 per month, for instance. So OCI, using Oracle Enterprise Linux, they come in around $73 per month. That's 67% less expensive than AWS and Azure. That's pretty impressive pricing to me.
Very impressive indeed.
So when we talked about AWS and Azure previously, we highlighted one of their superpowers, namely the ability to use fractionalized burstable CPUs. In cases where you're not needing all the processor power all the time, this option makes the economics look really attractive. While OCI doesn't really do fractionalized burstable CPUs, it does have a superpower. It can do flexible shapes. So what these allow you to do, these flexible shapes, allow you to specify CPU and RAM independently. So instead of being stuck in a certain instance class and kind of being in the middle, you can pick what you need here. So if you have a scenario where you're trying to optimize for processor licensing, this is absolutely huge. Give the server as much RAM as you want and as few CPUs as you can get away with. And this can have a huge impact on your overall cost because software licensing can often make the infrastructure look like a rounding error.
That is pretty cool, Tony.
Sure.
Next, we're going to discuss storage options. But before we get there, let's review some of the JD Edwards performance requirements we've talked about previously. Frank, last week and the week before that, you outlined what were the main performance bottlenecks for JD Edwards. I hate to ask this, but could you summarize that for us again?
Sure. It's basically deja vu cube now. I'm definitely repeating myself in these presentations on some of this stuff. But basically for JDE, the two main bottlenecks are going to be the speed of the database server and the single core clock speed on the enterprise servers.
So on the enterprise server, can we improve performance by just adding more CPU cores, even though they're at a slower clock speed?
Not really. I mean, again, what you're really coming down to, you're improving concurrency, but any single process like a UBE or a call logic kernel's thread, again, they can be multi-threaded kernels, but it's still running on one. You separate the batch job into, either a load balance configuration or you can have multiple versions with data selections. But the higher clock speed helps the compute intensive processes such as financials and MRP or some of the job and project costing modules as an example.
So when we were talking about this last week, we had discussed how, like in the interstate system is a really great example, kind of differentiating between clock speed and the speed of an individual core. The cores are like the number of traffic lanes, and the clock speed is the speed at which the individual is traveling. More cores don't make that individual vehicle go any faster.
Exactly. Basically, you've got more lanes, and that could help an individual vehicle avoid a traffic jam.
Okay, so switching to the database server, what affects my speed there?
Well, again, the two main things there is the amount of RAM and the speed of the storage.
So what about the speed of the CPU on the database servers?
In most cases, it doesn't really matter.
So I want as much RAM as possible with as few CPU cores as possible.
In many use cases, yes.
So kind of like what Tony was talking about earlier with those flexible shapes, we could use that to construct something that was ideal for JD Edwards with just the couple cores that it might need to actually handle the OLTP workload, but with the massive amounts of RAM that you're needing for optimizing performance.
Yes. Yep.
So Frank was just talking about how IO speeds were critical for from the storage perspective. Let's walk through what the options are on the various clouds and how OCI stacks up. So to start the discussion, we're going to use a scenario where let's say we have a database server and it's got 500 gigs on it and you want 50,000 IOPS. Now, the first thing I want to call out are most of you watching this presentation are not going to need this amount of IOPS. I know Frank probably considers that blasphemy. There's no such thing as too many IOPS out there, but economics constraints are real. But for a subset of users, and let's call them probably about 20% of the JD Edwards community, you are going to need an extreme amount of IOPS to make this perform. So let's walk through the options. Oh, and actually, first of all of the clouds can do this. So you're able to deliver the performance that you need, regardless of whether you're talking Azure, AWS, Google, or Oracle. But let's walk through how we do it on each of those clouds and talk about the performance or the costing implications. So first of all, on Azure. So we're going to use Ultra Disks, and those Ultra Disks priced out in Northern Virginia come in just under $2,600 a month for that 500 gig and that 50,000 IOPS. So doing the same thing on AWS, it's going to be a little bit more than that, coming in at almost $3,000. And we're going to utilize IO2 plus the 50,000 provisioned IOPS on that. So for Google, we're going to use Extreme PD storage, and that's going to come in just under $3,700 a month. And then wait for it, drum roll, on OCI, It's $30. So literally 500 gig of space, 50,000 IOPS, $30. Now, one thing that's also important to call out here is you need to be running on an instance type on all of these clouds that is sized appropriately to be able to handle that number of IOPS. If you, like in the case of AWS, if you've got like a T3 2x large you're trying to use for the database and you provision this, it's going to be like you've got the super fast disk, but you're trying to drink it through a coffee stir stick. So always be aware about the sizing of the instance when you're doing this. But I mean, these economics for OCI are just absolutely crazy when it comes to this storage. So this is, like I said, 20% of the JD Edwards community falls into this scenario. So let's now talk about everyone else. This is where the bulk of the user or the user community is going to fit. And so what we'll do in this is we're going to drop down one class of storage and talk about what is the fastest solution we can engineer on that cloud and how much is it going to cost. So for Microsoft, we're going to use premium SSD P2 disks. So it's going to be 512 gig in size there. So they have set ratios that you have to pick from. So we'll get the 512 gig. We're going to get 2,300 IOPS off of that. So AWS will use GP3 storage. So dropping from IO2 down to GP3, and we'll provision 16,000 IOPS. It's going to cost us about $140 a month. So that is so much better than the $3,000 we were just looking at for AWS. We take a look at Google, and with Google using zonal SSD, we can get it down to about $94 per month, and that's going to get us 15,000 IOPS. And now for Google, for OCI, we're going to drop down one storage tier, and we're going to be able to get 25,000 IOPS for $21 a month. So professional tip, if you're using OCI, pay the extra $9 and get the 50,000 IOPS. It's sort of crazy not to. So one other thing I want to talk about is just kind of the difference. So if you see on the left there, the dollar signs and the turtles, this is basically to highlight the economic difference and the performance difference. So kind of going up to Google, you're going to pay 4 times more than OCI. And it's basically going to be 1.5 turtles slower, 1.5 times slower. If you take a look at AWS, it's going to cost 7 times more, and you're going to be 1.5 turtles slower. And in the case of Microsoft, it's 3 times more that you're paying for it. And I'm losing count here, 4, 8, you're 11 turtles slower. So the moral of the story is if you can put the workload on OCI, use the 50,000 IOPS, get that extreme performance, and save yourself a bundle.
Those are some crazy good prices, Paul. Let's talk. I want to talk about another major cost that a lot of customers get surprised by, and in fact, I've been surprised by when I was a rookie and dealing with the cloud. That's going to be egress charges. So what data egress is just as it sounds. It's simply data leaving the cloud environment. So moving data into the cloud is pretty cheap, and most of the time it's free. However, a lot of the cloud providers like to act like Hotel California. They'll let you bring it in anytime you want, but they're not going to let you get it out of there. It's just not going to happen. So what I want to do is examine the cost of moving 10 terabytes of data out of each of the 4 providers. And we're going to start off with Microsoft. So they actually do offer the first 5 gigabytes of data exiting their cloud environment for free. It's kind of generous of them. But for 10 terabytes, we're looking at about $800 in a 1-month charge just to get that data out of the cloud. Now, Amazon's like, so they're clocking in around 450 for 10 terabytes exiting the cloud. And Google is costliest. Much like they've been throughout this presentation, they come in a whopping $1,100 just to move 10 terabytes of data egress. Where OCI comes in again and disrupts the market is they actually allow that 10 terabytes of data to leave their cloud for free. They don't charge you for the first 10.
Yeah, that's a really nice data limit. I wish Comcast Internet for Home was like OCI, but they do have a nice unlimited option for the data.
For sure. So that's for sure. So yeah, Oracle Cloud does offer that 10 terabytes for free, which is it's great. It's really useful, especially when I've done labs and things like that, and when I've brought new customers in at the very beginning, they don't have much data egress. But let's take this a step further. So what happens after the 50 or the 10 terabytes? So we're going to look at 50 terabytes. So, and I want you to keep in mind that data egress could be anything. It could be user traffic coming in and out of the cloud. It could be third-party integrations that are sending data out to the internet to like another web provider, you name it. And it basically anything leaving the internet. So Microsoft is going to come in for 50 terabytes to send data outside their cloud at $3,399, almost $3,400. Amazon's cheaper. They're $2,200 and $2,250, and Google's around $4,310. So we can see a big price difference here, even between these three. But let's take OCI numbers here and watch how disruptive they actually have been. So they're going to only charge $348 to transfer 50 terabytes of data out of their cloud. So it's almost guaranteed that this is going to impact your business if you are going to use a cloud provider. So you're going to deal with data egress and the costs that are attached to those. And Oracle's drastic price difference is absolutely felt when it comes to real world numbers for any business.
Yeah, that's absolutely crazy numbers, Tony. One of the reasons Oracle has had so much success with video conferencing vendors, especially during this pandemic time, is because of these egress charges. If you think about how video conferencing works, egress is one of the big things that's happening there. It's the most expensive line item on their cloud charge. And that's why you see those video conferencing vendors adopting OCI is primarily directly around this math here. I mean, it's kind of hard to compete. So let's shift topics now and talk a little bit about Oracle database licensing. So first thing I want to start out with is for the majority of JD Edwards customers that are on here today, if you're licensed by Oracle Technology Foundation, you can ignore this. This is not applicable to you. You're in a great position. You can deploy on any cloud that you want. It's not going to impact your licensing. If, however, you do have Oracle database and it is licensed by processor, there's some things that you need to be aware of. So the first is on Azure and on AWS, one processor license is going to cover 2 vCPUs. If you're doing this on OCI, that same processor licensing for Enterprise Edition is going to cover 4 vCPUs. And if you're licensing Oracle Standard Edition by core, that one processor license will cover 8 vCPUs. Now, why this is really a big deal is if you're moving from on-prem, chances are the way you're licensed today is already matches what you're going to have when you would move to OCI. So that one processor license that you have today is probably covering 4 vCPUs for you. So if you move that workload to AWS or you move that workload to Azure, you're probably going to be in a scenario where either you have to go out and buy more Oracle database licensing to deploy there, or alternatively, reduce the number of CPUs that you're running. And that might not be a great option from a performance standpoint. Tony, can you walk us through a couple examples of deploying this processor-based licensing on the various clouds to show us what the economics are? And one other thing to bear in mind with Tony's examples is this is all going to be based around Oracle list price. Chances are you'll be able to negotiate a little bit better numbers than these, but this will give you a very good sense of what those ratios are.
Absolutely. So yeah, the savings between the two can actually add up fast with those licensing options that OCI provides compared to, say, AWS and Azure. So licensing a 16 vCPU with AWS and Azure is going to cost you around $380,000 up front, and then you're going to have an $83,000 annual support charge. That's a pretty big charge. So if we look at Oracle, you're going to see 190K. It's a lot cheaper. So the ratio here is going to be great, and it's twice as expensive to run on the other competitors as it is to run it on Oracle Cloud.
Oh, absolutely, Tony. So the one thing to think about whenever you're moving workloads to the cloud before you think about anything else is understand what your software licensing liability is. Do the math and get that right. Because you can end up being in a world of hurt if you don't do that up front. So let's shift gears now and talk about the last reason for why someone would want to go to OCI. And that's innovation. We want to spend some time talking about the efforts that Oracle's made on JD Edwards to make Enterprise One behave more like a modern application on OCI. And the idea of a modern application is the ability to dynamically scale up when you're at a really high usage point, scale down when the users aren't on the system doing stuff, and to be able to do that all dynamically without having to take an outage on the application to make the change. Clayton, can you tell us a little bit about these innovations from Oracle, as well as some other things like single sign-on?
Yeah, thanks, Paul. So with the JD Edwards development team, we have actually been trying to focus our product being able to work on obviously any cloud, anywhere, anytime. That's one of JD Edwards's long-standing advantages is our platform agnostic. But we are Oracle at the end of the day, and so when we started doing Oracle Cloud, one of the first things that we did with the JD Edwards development team was try and figure out some ways that, again, we can innovate and we can take advantage of some of the OCI tools that they're providing, and again, kind of piggyback off them to make sure that, combined, we are offering some of the best in class, not just cloud, but also infrastructure and software that will run on it. So one of the first pieces that we looked at was elasticity, as Paul said. Elasticity to us means being able to scale up and scale down and to meet the resources or workloads that your business needs. Now, obviously, that can fluctuate over time. It can fluctuate over month to month or year to year, depending on how your business runs, or if you have mergers and acquisitions, then you may have to have the scale up and scale down capabilities at your fingertips at any one time. So when we take a look at elasticity, we felt like we were in a pretty good position. We've always been able to scale JD Edwards to either a small amount of users or to a large amount of users. But to be able to drive that based off of the workload is where we're actually taking the innovation to the next level, especially with OCI. So with OCI, they've got some really nifty tools that revolve around auto-scaling your instances as you've defined them. We also want to take advantage of being able to leverage database technologies, which we'll talk about in a little bit as well, that Oracle provides within the Oracle Cloud, like Autonomous Database you've probably heard about. And then finally, there's some additional infrastructure pieces such as Docker containers that really can be leveraged to take advantage to quickly spin up and spin down your instances or be elastic within the JD Edwards software as well. Now, all of these things are not necessarily native to JD Edwards, but what we did was we took our software and we were able to make sure that we can run against that and we can adopt quickly to an environment that does scale up and scale down. So these are some of the major innovation things that we've done on the elasticity side and that we're continuing to work forward to as well, because we've got a number of large customers out there that are driven based off of these workloads and want to make sure that they have the capabilities to leverage the pay-as-you-go nature that OCI provides for you.
Yeah, this really takes the grid commodity combo web app server architecture to a whole nother level for E1. It's awesome.
All right. One of the examples of elasticity and one of the projects that we put into place within the last calendar year, I affectionately call virtual batch queues or VBQ. This has been a long-standing project that we've had enhancement requests for from our Quest user group community, the technical SIG, as you will. And one of these projects that we've really hoped to get done internally as well, and feedback from our business partners for years and years and years. But with elasticity and OCI, we really found that this was a optimal time to do so. As you know, JD Edwards is primarily made up of two types of functionality. You've got the interactive users that are on the web client, and then you've got your batch pieces that run in the background and do either processing or reporting, depending on what you want to do there. Now, historically, we've been very successful in being able to load balance and be elastic on that web end, the interactive tier. But the back end tier, the virtual, the queue tiering, the UBE queues, depending on your platform, have not always been the easiest to configure or to be able to load balance between. So we've come up with virtual batch queues within the 925 tools release. Again, this was within the last calendar year. And what this does is it allows you to be able to submit to a single virtual queue or virtual machine or virtual server. And then any number of servers can be assigned or provided in the essential farm of batch servers and be able to accept that job and be able to run the job as defined. Now, the important part is also the ability to come back and retain the output of the job. So historically, this was one of our gotchas, was you could be able to submit the job anywhere you wanted to, and it would have no problem. But let's say you come back days later and you want to be able to retrieve that output. That's usually where things got pretty sticky. And with virtual batch queues, we've solved that problem. So you have the ability to come back days later, anytime on any server, and be able to retrieve the output as it was run, no matter when it was run. So there's a lot of great features that are involved here with virtual batch queues. I highly recommend you guys get out there and take a look at some of the 925 innovations, for which this was one of. And just like Paul said earlier, get in and apply it to your system and take it for a spin. So really exciting.
Yeah, this is really a great feature for E1 Linux and Windows servers that definitely simplifies the mobile batch server architectures. The virtual batch queue is really capable to help you add and remove batch servers for various planned events or even unplanned outages.
Absolutely. Another area that we're trying to take advantage of some of our cloud-based PaaS services or platform as a service is Identity Cloud Service. Identity Cloud Service, or IDCS, is the equivalent of running Oracle Access Manager. And as most of you may know, Oracle Access Manager is our preferred and supported solution for doing single sign-on authentication and authorization. Now, OAM and IDCS are capable of linking to any type of LDAP server you've got on the back end. And, this has been a great way for us to be able to sign on to JD Edwards once and be able to continue to leverage that sign in via token-based authentication tools. No matter where you sign in, again, via another web browser or mobile device or whatever, once you've got that token, you're able to sign in. You're able to keep your session alive and maintain a single sign-on and single password to be able to connect the JD Edwards and any other Oracle application that's linked to OAM. So with IDCS, this is just, again, our equivalent service that's running out there in the cloud. And we have taken good steps in making sure that we have the capabilities of being able to launch this as a service and integrate it directly with JD Edwards, again, as the single supported SSO solution out of the box from Oracle.
Yeah, I'm really looking forward to this feature since installing or configuring, Oracle Access Manager, like on-premise at a customer's infrastructure for E1s, it's not always been the easiest consulting task from my own personal experience.
Yeah,
And
even though we provide it with the Oracle Technology Foundation, it is a beast of a product to try and get up and running, and often requires, some particular expertise to get it done. I mentioned Oracle Autonomous Database, so this is another way that we really differentiate JD Edwards running in OCI versus other clouds. Obviously, we run in other clouds just fine, but when we come back to customers, we really want to have differentiators, and the database that you're running in the back end is always one of the proven ones. If we can't beat you on price, or you can't be convinced off that price that Paul and Paul was showing you earlier, then we really want to show you how performance can be changed just by simply going to one of the Oracle supported databases that's running in OCI. Autonomous database, there's lots of buzz around it being able to automatically patch your system, and then it has some new connection pooling capabilities and so forth. We wanted to make sure we took advantage of some of those features, and we did not have that as a hurdle. We're not a hurdle towards customers going to autonomous database. If you have the downtime planned with your database, or no downtime planned with your database, we want to make sure JD Edwards is not going to also require any downtime just because of lost database connection. So with 9243 and above, we formally supported the dedicated ADB solution, and we're going to continue to provide additional feature-based support within our JD Edwards software, as I'll show you in our upcoming roadmap, that will take advantage of some of the, again, native technology pieces that the autonomous database and Oracle database in general provide. But at the end of the day, you really want to take a look at Oracle database, either the Extreme edition, which is essentially the Exadata edition, or the autonomous database, because these are things that you cannot find, performance-based features that you cannot find in any other cloud offering. They're only available from OCI.
And it's probably worth mentioning that a lot of this and the features that Clayton's talking about are not just future features that are going to come out for support. So I had a customer, we did an upgrade and migration, moving them to OCI a couple of years ago. And for the database, we were using Oracle Bare Metal Database Cloud. So it's basically Oracle's database as a service. And we had deployed them on it. Things were running. We were using MVME for the storage, data guard to another availability domain. Everything was phenomenal. Performance was absolutely blazing. On average, the users were 2 to 3 times better response time than they had on their previous system. Until we got to 5 p.m. And at 5 p.m. every day, performance just tanked. And so we went in and we did some analysis, and it determined that the problem was CPU load that was being requested at 5 p.m. There was some kind of a third-party ETL operation that was basically pegging the CPUs, slowing things down. So because this was on Bare Metal Database Cloud, we were able to go in and through the CLI schedule at 4 p.m. just double the number of CPUs. And we're only getting billed for it. We're getting billed by second, but only for the number of CPUs that we're using. So we doubled the number at 4 p.m. We took them away at 6 p.m. Suddenly 5 p.m. became the best performing hour of the day. And here's the really crazy part on this is if we had taken this exact same strategy on another cloud. So first of all, we would have had to have taken an outage to make the change. So that would have been very disruptive to the users. But probably more importantly is we would have had to have bought those additional software licenses. And in the case of this particular customer, that would have been around $400,000 that we would have spent on that solution. Given kind of that scale up, scale down approach over a 36-month period, it was like $3,000. $3,000 versus $300,000. I mean, it was crazy. This was like my very first taste of, this whole elasticity. And, we've been hearing the story for years, but to actually see it in the real world, in the wild, was just amazing.
And to close up with my portion here, I wanted to let you see some of just our dedicated cloud infrastructure projects that we have pumped through over the last couple of years. So as you can see, JD Edwards continues to innovate, and we continue to innovate based off of and to partner with our friends at our cloud and database teams. So, to kind of highlight what we've got on the right, so we've had quite a few things come out just this year as far as re-optimized reference architecture that's been published and available since April. We've done some performance characteristics based off of that. All this reference architecture has been vetted and actually worked on with several different partners, including my friends here at ERP Suites. So thank you guys for participating in that and making sure that we're on the right track for not just how we want to deliver our product, but also to make sense of best practices for running JD Edwards in cloud type architectures. And then later on this year, as I mentioned, we will be providing additional autonomous database features that are embedded directly into JD Edwards that take advantage of some capabilities. We'll be changing up some of our kernel processes to allow for automated reconnection if there's ever a database node switchover or a database reconnect that's required due to network problems. And then we'll be taking advantage of some of the IDCS pieces and validating them and formally supporting those out the door as well. So a lot of great things coming, a lot of great things we've already done, and JD Edwards just continues to try and innovate and leverage OCI features to create a best practices and best laid architecture for you.
Hey, thanks so much for all of that, Clayton. As you can tell, myself, Frank, and all of us are just so incredibly excited about what you've been doing and how you've been innovating the product. We'd like to shift our discussion now from performance and innovation to resiliency. And Tony, I'd like you to talk a little bit about what is the difference between in-region resiliency and out-of-region disaster recovery. And I know we've hit on this on previous Find Your Cloud presentations, but this is really an important concept for people to get right.
For sure. So yeah, let's start out with some terminology. So there is some differences between the clouds. So when we talked about AWS and Azure, we described an availability zone. So an availability zone is basically a data center or a collection of data centers within a region, and each region has multiple availability zones. So the availability zones tend to be close enough to where they're less than a millisecond apart. So you can treat them like they're the same local area network, but they're far enough apart that, say, a power outage on one road doesn't impact the entire region. So basically anything short of a natural disaster within that geographic region is going to be statistically improbable to take them all out at once. So Oracle does have this same exact concept with OCI, except they're calling them of availability domains instead of availability zones. As you can see from the diagram here, it's basically the same idea, but they allow you to separate that critical infrastructure to avoid outages.
Yeah, it is important to note for optimal JDE performance, you want to have everything running in the same availability domain. Even 1 or 2 millisecond latency between those ADs is not ideal. E1's very chatty, and the additional latency adds up and slows JDE down.
That is true, Frank. So, however, recovery into another availability domain is fast if you have to do so. So you can simply just recover the servers from object storage, and most of the volumes are going to be small, making it a really quick procedure if you had to. So that's definitely an option.
So when we're talking about resiliency, we should be thinking about availability domains. Am I correct in inferring that if we're wanting to think about disaster recovery, though, we should really be thinking about separate regions?
Exactly. Yeah. So I'd be very suspicious of anyone proposing that a separate just availability domain or a separate availability zone in any cloud for that matter, be calling that a DR. So that would not be a good idea. So for customers based in the US, a good rule of thumb is that your DR should always be in a separate FEMA region from your production systems. You don't want your failover locations too close together geographically. That's something we always make sure that we built into our architectures for our customers.
Thanks so much, everyone, for all of this information. So let's recap our key takeaways from today's presentation. The first is that OCI has amazing economics around compute, Windows, commercial Linux, storage, and egress. So if what you're wanting to optimize for primarily is price, this is absolutely where you should start. One of the next things would be to take advantage of flexible shapes on OCI wherever possible to limit that software licensing exposure. Oracle needs half the number of Oracle processor-based licensing to run on OCI. That was as compared to AWS and Azure. So really important to keep that in mind. Next, use virtual batch queues. I want you all to go get on the latest tools version, implement virtual batch queues, and respond back to us. Tell us how that works. We are so excited about this because this really is modernizing the JD Edwards application. Scale up, scale down for database. This is only found on OCI. You can do it today with bare metal database cloud, with Exadata, and with dedicated autonomous database. And coming soon, shared autonomous. And then the last thing that Tony had just talked about, availability domains do not equal disaster recovery. So what cloud is right for your organization? What are the trade-offs? What superpower does each cloud have that you could leverage to your company's advantage? We'd love an opportunity to help game out these options for you. Please join us next week for the last in our Find Your Cloud series with our exploration of private cloud. Email us at findyourcloud@erpsuites.com with any questions or to schedule a free assessment. On behalf of the entire ERP Suites team and Clayton, thanks so much for attending.